यस, गुड मॉर्निंग स्टूडेंट्स। देखिए, हम बात कर रहे थे रिलेटिव एंगुलर वेलोसिटी के बारे में और मैंने आपको ये बता दिया था कि रिलेटिव एंगुलर वेलोसिटी किस तरीके से किसी दूसरे पॉइंट के अबाउट कैलकुलेट करी जाती है। जैसे हम क्वेश्चन देखेंगे तब हमें ये चीज क्लियर होगी। लिखेंगे टू पार्टिकल्स 1 and 2 are moving with speed v1 and v2 in a given direction as shown in figure. This is the figure for it. It is moving with v1 here and it is moving with v2 here. This angle is theta 1. This angle is theta 2. This is point 2, point 1, and the length between them is L. Now we can solve it like this. We can see easily this is a straight line basically. This is a straight line. Calculate the velocity. Calculate angular velocity of 2 with respect to 1. So it is moving with v1. And it is moving with v2. With the velocity theta 2 या angle theta 2. तो calculate the velocity of 2 with respect to 1 first of all. So we can say easily, देखो, we have to calculate the component which is perpendicular to it. Now what is the component which is perpendicular to it of v1? This is the component which is perpendicular to it. It is v1 sin theta 1. And this is the component which is perpendicular to it. It is v2 sin theta 2. Right? So these are the two components, that is v1 sin theta 1 and v2 sin theta 2. We have to calculate component of relative velocity perpendicular to line joining particle 1 and 2. So what is the component of relative velocity? This is v2 vector perpendicular component. v2 vector perpendicular component minus v1 vector perpendicular component. v2 now what is v2 vector perpendicular component? It is v2 sin theta उस डायरेक्शन में, इस डायरेक्शन में कंपोनेंट लेंगे तो दोनों ऐड हो जाएंगे. It will become v2 sin theta 2 plus v1 sin theta 1. अगर दोनों ऐड कर दूं मैं तो व्हाट इज द कंपोनेंट ऑफ रिलेटिव वेलोसिटी? इट इज दिस. तो व्हाट इज ओमेगा? एंगुलर स्पीड ऑफ 2 विद रिस्पेक्ट टू 1. दिस इज दिस कंपोनेंट. plus V1 sin theta 1 by distance between them, and distance between them is given L divided by L. So it is V2 sin theta 2 plus V1 sin theta 1 by L. That is the magnitude of the relative angular velocity, right? Next. Next is two particles calculate magnitude of angular velocity of particle 1 with respect to fixed point O. Well, this is the thing. This is 0, 0. This is 0, minus d. And this is d, 0. And it is moving in this direction with V1. This is fixed point O. And this is the A. So we have to calculate its angular velocity. So we know कि line join करो. This is the line joining. This is the line joining. If this is D, this is D. This is angle 45. If this is 45, then this angle is also 45. The component of it along the perpendicular to it. This is the component perpendicular to it. This is V1 cos 45. It is V1 by root 2. Right? And this is the line here. So if this angle is 45, this angle is also 45. So we can easily calculate. This is V1 cos 45, V1 by root 2. And this is also 45. So we can easily calculate the angular velocity of 1 with respect to fixed point O. वो कितना होगा? It is a perpendicular component. V1 by root 2 by distance between them. If this is D, this is D, what is the distance? This root 2D. So it will come out to be V1 by 2D. That is the magnitude of angular velocity of A with respect to O. Is it clear? So this is the relation for it. Next, there is one more new concept for it. It is called radius of curvature. रेडियस ऑफ कर्वेचर देखो, फॉर अ कर्वीलिनियर मोशन radius of curvature at any position is the radius of circle that can fit at that position. Like this is, let's suppose the curve. We want to calculate the radius of curvature at point A, at point B, or at point C. So the most fitted circle at this point. Now this is the fitted circle. इसकी जो radius of curvature होगी, that will be called radius of curvature at this point. Like this. Radius of curvature at this. Right? तो इसको देखो निकालने का तरीका क्या होता है? We can write AC is what? At this time, its velocity is along the tangent. Here also, the velocity is along the tangent. So we can write AC is V square. टेंजेंशियल वेलोसिटी के कंपोनेंट का बाय आर. तो व्हाट इज द रेडियस ऑफ कर्वेचर? यू कैन राइट जस्ट वी स्क्वायर. इस एग्जाम्पल की हेल्प से समझो आप इसको. अ बॉडी, बॉल ऑफ मास 1 kg is projected from ground with a speed of 10 meter per second at an angle 37. Calculate radius of curvature at point of projection. So this is the case. मान लो ये प्रोजेक्टाइल है, right? This is the direction of this U. This angle is 37 degree. Now the component that is perpendicular to it, the G is acting in downward direction. and this is a direction which is centripetal. Now the component of G in centripetal. This is the centripetal direction. So this angle is 37, this angle is 53, this angle is also 37. This is 37, so this is G cos 37. What is G cos 37? This is AC. What is G cos 37? Cos 37 is 4 by 5. AC. So if AC is calculated, now what is AC? U square by R होगा यहाँ का. U is how much? 10 meter per second. So AC is 4 by 5G. U square 100 बनेगा by R. R will come out to be, that is 10 into 5. This will remain 10, 10 into 5, 50, 50 by 4 meter. R is 50 by 4 meter. Is it clear? So that is the radius of curvature at the point of projection. So we can calculate like this. जैसे एक क्वेश्चन और देखेंगे रेडियस ऑफ कर्वेचर पे. देखो नेक्स्ट क्वेश्चन देखेंगे प्लीज. A particle is projected with 10 meter per second at an angle of 53 degree from horizontal. Calculate the radius of curvature of path at half of its maximum height. ये प्रोजेक्टाइल हो गया. Its initial speed is given how much? 10 meter per second. At an angle of 53 degree. So we can say the component that is perpendicular to it at half of its maximum height This is H. This point is P. It has a tangential direction like this. The speed is in this direction. Having two components. This is Vx and this is Vy. And the centripetal direction is this. This is the centripetal direction. Half of its maximum height. तो पहले Vx और Vy निकालो. What is Vx? वो तो डायरेक्ट निकलेगा जितना Ux होगा. That is U cos 53. Cos 53 is 3 by 5. U is 10. It is 10. 6. And this is U sin 53. U sin 53 is 4 by 5. That is 8. Right? Now, what is the component of Vx and Vy? So it is U cos 53. What is the component of this? Vy कितना होगा? Vy होगा is equal to Uy square plus 2Ay into Sy. What is H? What is H? H is U square sin square theta by 2g. ये Uy square by 2g. Uy square is 64 by 2g is 20. Maximum height. That will come out to be 32 by this 3.2. What is Vy square? It is Uy square. Uy square is 8 square, 64 plus 2 Ay. Ay is minus g into Sy. Sy is how much? H by 2. 64 by 2. .6. So it will come out to be how much? 64 and this will be minus 32. That will come out to be how much? 32. Vy square. Right? अगर ये इतना निकला है तो what is Vy? Root 32. And this is Vx which is 6. तो ये कौन एंगल निकलाएगा? अगर ये थीटा निकलाया तो ये कितना निकलाएगा? G is in downward direction. ये AC है तो ये कितना निकलाएगा? That is theta, this is theta, this is also theta. So what is G? What is AC? AC is G cos theta. Right? And what is tan theta? That is V square by R cos theta. What is V square? It is under root of, V is under root of this, so it is V square is Vx square plus Vy square. What is Vx square? That will be 36. And what is Vy square? 32. 32 plus 36. 98 by R. This is G and this is what? Cos theta. Now what is tan theta? Tan theta is, this is Vy upon Vx. So what is cos theta? Tan theta is Vy upon Vx. So what is Vy upon Vx? Vy is root 32 by x. Vx is 6. So what is cos theta? That is Vx 6 upon under root of Vy square plus Vx square root 98. और 6 अपॉन रूट 98। जी को आप लिख लो 9.8, तो कटिंग करेंगे तो 10 बचेगा। तो व्हाट इज आर? 10 इंटू रूट 98 बाय 6। This will become 10. Approximately it is 100 by 6 R. Clear है? So this is the radius of curvature at half of the maximum height. This is the radius of curvature at half of the maximum height. Is it clear? Next. Next is the dynamics of circular motion. Yes, देखेंगे. Next is the dynamics of circular motion. When a body moves in circular motion, then direction of its velocity always changes. And it has always centripetal acceleration, full stop, which concludes that a body in circular motion must have a component of force towards center called centripetal force. So, any real force component provides लाइक एग्जांपल देखो आप, जैसे हॉरिजॉन्टल सर्कल है, string is moving in horizontal circle. If it is moving in horizontal circle, the tension will act as centripetal force. Like if the body is moving, मान लो this is the path, its center is at this position, it is at this position, the center is at this, so it is mg is acting like this and fn is acting like this. Here mg minus fn is acting as centripetal force. F centripetal. या कुछ और चीज ले लो आप, like circular turn है, a गाड़ी is taking a turn, its center is at this position. If it is taking a turn and center is at this position, so we can easily judge it has a tendency to slip outwards, so friction will act inwards. This friction will act as centripetal force. F centripetal. Are you getting it? So any real force component will act as centripetal force always. Right? लिखो इसको.